Again, with you here is Mr. Michael, aka Sir MTH. We are going to be precise on this concept, projectile, and what we see in projectile in different aspects, or rather the terms, definitions of terms of the three particles that are related or that are relating projectile. So quickly, I want to move with the first particle, which is talking about time of light. All right. So, and the second one is the range of projection. Okay. And then the third one is the maximum height. Okay, the maximum height. All right. So these three are what we're going to be dealing with. We're going to be precise on them. But before we do this, let's assume a young guy shots a gun. This is a guy shot a gun. From the distance he is, the horizontal distance from his feet happens to be R, which is the range interval to which he has deported the projection. So from there he shot the gun, and the gun went to the sky just like this. And I've got to this very peak. This is the peak, this is the maximum height the bullet could get to, and then it returned to the floor of the same projected line. Now the height of this individual is the calculated what? Maximum height, or the peak. We can also call it the amplitude of the projection. However, it took some time, T, U over G, which is the speed and the gravity that resisted the flow of the projection. Okay? T is the reason why it can take it takes more time, because you know the higher the time, the lower the gravity. So if the gravity is higher, that means the time taken will be what? Will be lower. And if the time taken is very, very low or is higher, that means the gravity is little or no gravity. That means there are little or no gravity. So hence we have that the U over G, the speed is determined. The speed determines the time, and that means the time is proportional to what? To the speed, which is the U here. So the same U, or the same time figure, is taken for U over what? G at the return of the same bullet that was projected at this maximum height. Hence, we have that time of flight is a calculated U of flight and U over G of the returning bullets down to the foot of the boy that projected or that knocked out or shot out the bullet. However, this gives us what? 2U over G. But most of the time, we do have a projected angle at the horizontal. Horizontal resolution is Vx equal to let's take it as mass and gravity sine what? Theta. And while the vertical resolution is Vy equals to what? Mg cos what? Cos theta. This is normally what we understood as vertical and horizontal resolution while we are dealing with what? While we are dealing with what? With the concept or the idea for what? For projection or projectile. But however, the range is a calculated figure for the distance covered at the horizontal plane. Okay? The interval covered by the what? Horizontal plane. And that gives us what? That gives us x equal to ut. The distance here, r. So when we say r equals to ut, that implies that my u, this becomes u multiplied by my t already is given to us as this. So that gives us what? 2u over g, and that brings us to what? 2u squared over g. Very simple. So here we have gotten the range as this, the time of flight as 2u over g with this same analysis. So we can still bring to birth another form. The maximum height reached, this is the maximum height reached. Okay? So the maximum height reached, two concepts or two ideas are noted here. The first one is the concept of what? The projected value, the projected material or particle, and the what? And the returning material. So, however, at the very point when a body is projected to climb to get to the maximum height, V is always maximum, because my V here is the initial velocity, and here my gravity is what? Negative. And here also my U is what? 0. Because U, final initial velocity is not respected, but final velocity is what? Respected. So at the very point now, my final velocity here, this is called final velocity, right? So sorry, final velocity should be working on here. So here 0, and here what? Maximum. The initial is what? Maximum. So here now, my V is equal to what? Maximum, while the final U is what? 0. Now, at the point of 0, that is at the point of return, my gravity is what? Positive. So using the general equation of what? Of motion, x equals to ut plus or minus 1 over 2g t squared. You can believe with me that when my u is 0, what happens? When my u is 0, what happens here? I will have 0 times t, and my gravity becomes positive because it is respecting gravity. So we now take plus 1 over 2g t squared. Hence, we are having s is equals to what? 1 over 2g t squared. Remember, this distance here is replicated as what? The height, the maximum height. So hence, we are having what? The h is equals to what? 1 over 2 multiplied by g. My g is acceleration, which is given to us as, if you make g such a formula from here, given that my t is equals to u over g, right? From here. So make my g such a formula, we have u over what? T. Am I right? So bring it here, we have u over t for g multiplied by t squared. So this cancels this, and then we're having 1 over 2 ut. That's all. So 1 over t ut. What is my u? My t here. My t from here is what? 2 ug. So possibly let's make it what? U over g. So bring it here. We are having what? Finally, my height is equals to 1 over 2 times what? U dot u over what? G. So we have it as what? U squared over 2g. U squared over 2g. That's the final resolution for this. So summary, my t, time of flight, is equals to what? Total time of, this is total time of flight. Time of flight is the total up and down, both going up and going, is 2u over g. Or time to reach the maximum height is u over g. This one is what? U squared over g. And this one is what? U squared over 2g. Let's solve some questions regarding to this. A particle is projected at an angle of 30 degrees to horizontal with the speed of 250 meters per second. Calculate A, the total time of flight of the projectile, B, of the particle rather, B, the speed of particle at its maximum height. Let G be equal to 10 meters per second. The parameter here says that U, which is the speed, is equal to 250 meters per second, and then G is 10 meters per second square. Theta angle given to us there is 30. That is the projected angle. So, however, time of flight, we already know that it was 2u over g. This is time of flight, not time to reach the maximum height. So, and but this angle, we're going to multiply it by sine theta. Okay, and that will give us 2 times 250 over 10 multiplied by sine 30. So, you know, here goes here. This is 50 times what? 50 times sine 30. What is it giving us? So we have what? We have half of 50 is what? Is 25 seconds. So now, talking about maximum height here, we have it as u squared sine squared theta over what? 2g. You know, here we have to put the square theta because if we had used the normal 1 over 2 blah 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 g t squared, if you derive this, making my t to be equals to u sine theta over g, you will get this. Please go home and try it. Try it there. So you get this. So we have this is equal to, my u is 250 multiplied by 250 and multiplied by sine of what? 30. All of them squared divided by 2 times what? 10. Okay? So we get it. This is 20 here, right? So 250 times 250 is giving us what? What is it giving us? 62,500 times multiplied by half. 0.5 times 2 is 0.25, right? So all divided by 20. Alright, so we have multiply this through. What do we have? Is divided by 20 rather. 25 times 625 divided by 20. What is it giving us?